Okay, in this video we're going to discuss how we do long division with polynomials. So in this problem we have 2x to the third minus 25x squared plus 66x plus 48 divided by x minus 8. So I'm going to write this x minus 8 outside. We've got 2x to the third minus the 25x squared plus 66x plus 48. So in this process, we're going to look at the first term. We're going to say how many times does x go into 2x to the third. If it helps you, we're going to write over here to the side 2x to the third divided by x. Well, 2x to the third divided by x is just 2x squared. So I'm going to put that over the squared. So x times 2x squared is 2x to the third. 2x squared times negative 8 is negative 16x squared. Now we're going to subtract, which subtracting basically changes each of these signs. Makes that a plus. Those cancel. Negative 25 plus 16. That gives me a negative 9x squared. And then I bring down my 66x. Now I'm going to ask myself again, how many times does x go into negative 9x squared? So you might write over to the side, negative 9x squared divided by x. Well, we know that's going to be a negative 9x. Well, negative 9x times x is negative 9x squared. Negative 9x times negative 8 is positive 72x. Again, we're going to subtract, so that's going to change each of these signs. Makes that a negative. So those cancel. 66 minus 72 is negative 6x. And then I bring down my 48. Again, ask myself, x times what gives me negative 6x? So you might think of it as negative 6x over x. That's just going to be negative 6. Well, that gives me negative 6x plus 48, which now when we subtract, again it changes both signs, we're left with a remainder of 0. So in this case, the answer is 2x squared minus 9x minus 6. Okay, let's look at a second example of long division. There are some instances when we're doing the long division where what we're dividing into does not have all of the degrees. So notice this one goes from 4 to 2 to 1, then no constant. So when I'm writing this one, I think it's a good idea to hold the place value underneath your division sign. So we've got x to the fourth plus, we don't have an x to the third, so I'm just going to say plus 0x to the third minus 2x squared plus 9x, and then still have space over here for, we don't actually have a constant there. Process is still the same. I'm going to say how many times does x go into x to the fourth? Well, x to the fourth divided by x, that's going to give me x to the third. So when I go about doing this, x times x to the third is x to the fourth. 3 times x to the third is 3x to the third. So now when we subtract, again, it's going to change both signs. I get a negative 3x to the third. I bring down my negative 2x squared. Again, I'm going to ask myself how many times does x go into negative 3x to the third. And again, that's going to be negative 3x squared. So negative 3x squared times x gives me negative 3x to the third. Negative 3x squared times 3 gives me negative 9x squared. Again, I'm going to subtract. That changes both signs, so now I get 7x squared. I bring down my 9x. Now I'm asking myself, how many times does x go into 7x squared? And that's just simply going to be 7x. So I have 7x squared plus 21x. Again, I do my subtraction. It changes both signs. So I get a negative 12x. Again, I don't have anything to bring down. It's just 0. So I might just put plus 0 here. I'm asking myself, how many times does x go into negative 12x? Well, again, if I write that over here to the side, it gives me negative 12. So I now have negative 12x minus 36. Again, when I subtract, it changes the sign, so I just am left with 36. Well, this 36 here is going to be my remainder, so I'm going to write this out to the side, plus 36 over x plus 3, which that's what I'm dividing by, and that goes on the denominator of the remainder.